Hi, I wanted to give you a quick tech demo about AI computer use and to basically show you how you can use language models to control your computer or control a computer, and in turn, how you can use this capability to automate basically anything. This is a long time coming. I prepared to do this demo for a while now. But I think it's just as relevant as ever, maybe even more so now. And there's a bunch of new tools and new providers, new models popping up that can do this. So I think I'll take the opportunity to talk about those as well. Before I jump into computer use itself, I just wanted to give a quick recap about tool calling in language models. I have a whole another tech demo about this. You can check it out on our YouTube channel. But in short, tool calling in LLMs is just getting some structured output from the LLM, so some JSON that we can parse and use to call some API, some function in our system, in our app. And, so you kind of describe this tool in the system message to the LLM. You give it, the schema to use this tool. And then the LLM, in response to some task, will give you a JSON that looks like, call this function with these parameters, and you can actually call this function in your app. You can get some result, maybe formatted that in some way for the LLM and pass it back, and then you run this in a loop, and here we go. You have an agent. So this is tool calling, and to talk about how to use tool calling for controlling a computer, I just wanted to kind of give a brief history of how this was approached in general and how we played with this in our tech research department. So the first obvious choice is HTML, because a lot of the computer use tasks are browser specific, so you want to control the web. You don't really care about the rest of the computer because you can do a lot of work on the web itself. A lot of the applications now are web-based rather than a native app on the computer. And the language models initially were just text-based, right? So you only could provide them with text context. So the obvious, first step is to just give them the HTML, the code representation of the web page, and provide that as context. And then what you get back as the tool calls is, the selectors and maybe some playwright code or whatever other automation tool. Where the LLM says click button with this selector with this ID or something like that. So this works surprisingly well, and we had some early success with that in tech research. But obviously it has downsides. The main one being that HTML is just not a good way to provide this context. It's very verbose. There's a lot of noise and a lot of information that are not useful to kind of get the idea about the page. So there's a lot of JavaScript, a lot of extra markup that's not necessary to display the page or to understand what's displayed on the page. But then on the other hand, there's also a lot of stuff missing. Whether or not something is visible to the user, sometimes you only get that from the CSS, and so you would have to plug that in some way. Or sometimes the error conditions, when an input has an error on it, maybe that's just signalized to the user visually by turning red or something, and maybe you cannot read that from the HTML. Or even like how things are spaced or ordered kind of vertically in this z-axis. So is this obscured by some modal or some pop-up, or can the user actually see it or interact with it? So these things make it a bit harder. And then even just like picking the right selector sometimes isn't as easy, because if you have an ID or a test ID, that's very easy, but a lot of websites don't. They don't kind of optimize for testing, and if you don't have a unique identifier for the button or for the element you want to interact with, it can be hard for the LLM to come up with the right selector for it. So then the next stage in this evolution is basically, let's do it purely from visual information. So now we have language models that can work with images natively, so they can take images in, tokenize them, and use them in their responding. So let's just do that, right? And give it a screenshot of the computer, and then expect tool calls of mouse movements or keyboard strikes or presses to kind of control the computer. This will, if you can pull that off, open up a lot more use cases for automation, because suddenly you can control the whole computer, not just the web. But it comes with its own, challenges. And the main one here is you really need a language model that can understand the screenshots very well. It has to have a very good kind of spatial reasoning about the screenshots, because if you want to move mouse around, it has to give you coordinates. Where to move the mouse. So it needs to know exactly where on the screen the target is, whatever the target is. And even kind of like relationally how things are spaced and so on. And this is not trivial. So out of the box, the early visual models didn't perform very well on that task. And then the second part of it is not just kind of understanding it spatially, the screenshot, but even understand the language of user interfaces, right? So we have this ingrained as humans because we use these user interfaces a lot. But it's not so trivial to kind of know, okay, this is probably a text input, so I should input some text in there, or this is a select box, and so I need to click it, and then I expect some options to pop out, and I need to select the options. Or even like scrolling, or this is underlined, so it's probably a link, and it will take me somewhere else. Things like that are kind of hard to understand. And then sometimes in the UI you don't even get kind of the accompanying text to say what the action is that this element will do. Sometimes it's just an icon, so you kind of need to build an understanding of what these different icons mean, and how to interpret them. And then the last point here, and I'm going to circle back to it, but it's also a very hard planning problem. So usually you don't want the LLM just to click a button, because you can do that yourself. But usually you have some, bigger task, bigger goal, like, book an accommodation on this website in these dates or whatnot, and kind of sequencing the steps that you need to take on the computer to actually achieve this higher level goal. That's also not trivial, and this is actually, a place where the LLMs struggle the most at this point, I think, because it's really hard to kind of come up with a good sequence of steps. But right now, let's get into the actual demo. I have a demo of kind of the first language model that was able to do this computer use effectively. That's where even the name came from. And it was from Anthropic. So they released the Claude computer use release back in fall. And so let me ask it to do something, and then as it works, I can kind of talk about how it works and how we can use it. So please open the browser and go to profig.com. And so the way this works, the way this is implemented is this is just another model, another language model from Anthropic that you can use through the API. And when calling it with the API, you can select, these special tools that Claude can use on your behalf. And they released 3 tools as part of this release. One is Computer, which kind of works with the visual interfaces. They have a Bash tool, which can issue CLI commands, and then they had a text editor, which can edit files on the computer. And you just select these tools, and the description of the tools or the system message associated is hidden from you, but Anthropic kind of injects the system message where it kind of tells Claude how to use these tools and describes the schema. They inject it in the background to the request, and so then Claude can answer with using these tools. Contrary to the name, the computer is not included, right? So it's just the model, and the model being trained on these interfaces and kind of understands in understanding the screenshots and being able to issue these commands. But the implementation of the computer itself is up to you. For Claude, it's just a hypothetical computer, and you just feed it screenshots, and it gives you back these actions. But you have to implement them yourself. And you could do that, if you are just, if you want to just automate a browser, you can do that using a browser. So, just spin up a Playwright instance, for example, and take screenshots with Playwright, send it to Claude, and then when Claude issues these tool calls, you can use Playwright to move the mouse around and click around or type. Here I'm using a container from E2B. So E2B is a very nice startup that provides containers for AI usage. So if you need your AI to use a computer, originally they had kind of just headless containers. But it's a safe sandbox for the AI to use the computer and run commands and whatnot. And they have actually a desktop offering as well, so they can spin up a computer that has a desktop interface, and it's perfect for use with the computer use cases. So the way it works, so I gave it the task, and then Claude can answer with text, just as any other language model. But then it can also give me back these structured tool calls. So here it's calling the action screenshot just to see what's on the screen. And then, again, it kind of plans the next step and gives me 2 more tool calls to move the mouse and click on, this is the Firefox icon, I think, yeah. And the way I have this implemented is basically when I see this tool call come from Claude. I take a screenshot of the web page. If it's a mouse move or typing on keyboard or whatever, I issue this command, or I actually do it in the container in the E2B desktop. And then I take a screenshot and I send it back to Claude. And I do this in a loop, basically, until it answers without a tool call, and I know that this is like a successfully completed task. One more thing I wanted to show you is you can use this for computer use, so you can use it to control the computer. But as I said, the computer is not necessary for it. It can be purely hypothetical. And it's more about Claude now having kind of this understanding of the screenshots and being able to do the spatial reasoning and give you actually coordinates of things and so on. So one thing we can do, one other task that you can use this for is basically for annotation, for example, right? So we can just say, please take a screenshot and give me the center and the bounding box of the reject all button. And I'm asking it to take a screenshot because I don't have kind of file upload implemented here. But you can imagine, the computer doesn't even have to be here. You can just send a request to Claude with a screenshot that you need annotated, that you need, some bounding boxes drawn into, and it actually understands the screenshot and it can give you the coordinates. So I think this is very powerful. And we can have it close the cookie bar as well, just as a side quest. So yeah, let's wait a little bit for it to do that, and then I'll move on to some other providers that have this functionality that can actually, work with computers, and I can kind of talk about it. But yeah, it's clicking now. Cookie bar is closed. $1 million startup is right here. So let's get to the next slide, and I want to talk about some other providers because, as I said, new projects related to computer use are coming up every week, and the progress is crazy in the AI field lately. So I just picked some, but this is in no way a comprehensive list. There's much more. This is just something I find interesting for one reason or another. So, of course, OpenAI has their own offering for computer use. Unfortunately, it's in the $200 tier. So I'm not paying for this, but not because it's not good. I think it is really good. They did a great job training GPT to control the computer. The reason I'm not that interested in it is because it's not an API. It's a product for them, and so you can use it to automate like your task, do shopping or booking of accommodation or whatever. But you have to do it inside the ChatGPT app, inside a product, and they don't provide it as an API. So for like automations that you control for like testing, for example, it's not that useful, unfortunately, but it's still very good, and I think hopefully they will release some API access to this as well. The second project I wanted to mention here is browser use. And this is more in the first camp, in the HTML-based camp. It's actually a hybrid approach, but it focuses on just browser automation. It doesn't do the whole computer. and it uses the HTML to actually kind of come up and draw these annotations, and you can then use those annotations and kind of this pre-processed web interface to you can use it with another visual model that's maybe not specifically trained for computer use, but it can still do visual reasoning, and it can kind of ID the element it wants to target, and then you can do that because you have these annotations and you know kind of from the HTML where these things are. Or you can combine it even just with the textual representation. So instead of feeding the LLM the whole HTML page, you can just give it kind of the list of interactive elements, and it can make some sense of that as well. And it works, surprisingly well. So I think this is definitely a very nice project to check out. The other thing I wanted to mention here, I unfortunately don't have a demo of this, but I think I'll come back to it. This is Qwen 2.5, and it's a vision model or vision language model. That's the VL in there, which is an open weights model, so you can actually download it and run it on your computer. It's pretty big, or they have different sizes of the model. So the 7B, the smallest model, you can probably run on a consumer computer as well. But for the bigger ones, you'll need an actual GPU with some with a lot of memory. But it's possible. It's open weight, so you can actually use this model, download it, and if you have the the GPU that can support it, you can actually run computer use on your Metal without an internet connection. And I think there's going to be a lot more open weights models that get this capability. So I think it's very, very nice to see this, and it's only gonna get better and cheaper and faster. So I'm very excited about this. And the last tool I wanted to talk about is OmniParser from Microsoft. So Microsoft released this a while back, but they just recently released the second version, so OmniParser V2. And this is also like a visual language model, but it has a very specific task, and that means it can be very small and very fast, and you can run it on consumer grade hardware. So you can actually run it on your computer. It can run on a CPU. You don't even need a GPU for that. And it kind of brings the understanding of the visual data, of the screenshots of the computer, to any other visual or non-visual LLM. So it can basically do annotations of the interactive elements or and even like the text content of the web page, same as we've seen in the browser use example, but it does it purely from the screenshot data, from the visual data. So we don't need the browser, we don't need the HTML kind of pre-processing to draw these annotations. We can use OmniParser for that, but then when we have the screenshot process in this way, we can actually use the data with any other language model or any other kind of technology or task that we want to use this for. So let's try it here. So if I click Analyze Screenshot, it's actually going to run OmniParser on this screenshot. So this is the E2B desktop that we have running from the previous slide. And it's a little crowded, but this is I'm drawing these annotations in with JavaScript. You can hide all this. I'm not sure. We can just turn it to show just one, so it's a little less kind of overwhelming. But it understands the screenshots and gives you a list of the elements that are in the page. And it kind of classifies them. It's icon and text, but most of the things are icons. But this is not as important. But then it gives you kind of its best guess on, is this interactive or not? So can I click it? Can I interact with it? Or is this just kind of some information, some text or something like that? And then it gives you the bounding box, so the kind of coordinates of this rectangle around the element. And you can use it together with some OCR library, and they provide this model as well in their kind of demo implementation. And so you can even see like what's the text inside of this element, and for the icons, what's the meaning of the icon. So this is very powerful, and you can take this, and now, when you have these annotations for the screenshots, you can send it to any of the models and kind of give it a better understanding, better grounding, it's also called often, of like where these elements are on the page. And so it can just tell you, I want to click the risk-free trial button. And, because from OmniParser where this button is, the model itself doesn't need to know the coordinates or have this capability of coming up with the coordinates. It can just say, click the risk-free trial, and in your application, you can actually kind of locate the button and click it yourself. So this is very, very powerful, and I love OmniParser, and I think it's going to bring a lot more progress into this field. So the last thing before I kind of conclude this demo, I wanted to spend some time to talk about the future of computer use, at least how I see it right now. And so again, this is not going to be comprehensive or kind of all-encompassing, but it's just some thoughts that I have about what I think is going to happen. As I said, we are only getting started in this field. So cloud computer use came out in fall, and then these other models kind of started coming out, across winter. But I think this year we are going to see a boom of use cases, and the models are going to get much better, much smarter, much faster, and so on. And one of the challenges I think that will get addressed this year, and that is still kind of the biggest hurdle in computer use, is the planning. So, they can do the simple task of click this button, fill out this form, and these kind of atomic pieces of automation very well. But the planning of the longer sequences of some more complex tasks, that's still something that needs work. And it's getting much better. I think even like that's something that I have to give to OpenAI operator. That model can do nice reasoning. Cloud computer use, also you've seen in the demo that it actually plans the steps somewhat. But I think we're going to see a lot more kind of tracing back. If the action didn't do what the model expected, to recover from that and maybe try a different approach and stuff like that. So I think we'll see a lot of progress there. One area that I'm particularly interested in is reinforcement learning. So we've seen huge successes with reinforcement learning for the thinking models. So, DeepSeek R1 or the O series from OpenAI, those are models that were trained using reinforcement learning, and it's because they were trained on what's called verifiable domains. So if you can kind of validate the answer of the model, you can just let it, try many times and verify when it came up with the correct answer, and use only those examples to train more and kind of reinforce this behavior. And computer use, to some extent, is not as easy as in math, for example, or coding. But it's also verifiable. You can spin up sandboxes or even the live websites and kind of verify if this product was put into the shopping cart, or if this message was sent, and so on. So you can verify if these more complex tasks were completely or completed successfully, and then you can reinforce the kind of thinking steps or the planning steps that led to those, and make rapid progress in the capability of the computer use models. And then one more thing, which I think is going to get very interesting, and it's also a very good research area, and it's actually something that we are playing with in tech research, is not using the computer use model for the whole kind of automation, but kind of as the model goes through the website or through the application or through the computer use case, learn a more kind of condensed, more informative but shorter representation of the web page, some structured kind of summary of the web page, sort of like an API for it, like how do I work with this page or this application, and then use that to navigate it and to complete tasks on it. So you can have kind of these two levels of thinking or of solving the problem, where one is the kind of down low of I need to move the mouse here to click this button and then fill this input element. But then, you can abstract this into sort of an API layer or into this more condensed representation, and have a more like a more capable thinking model at the top that just works with this representation, but it can actually do the planning much better and kind of use this API that the computer use model learned and prepared to finish tasks or do some automation on the application or on the website. So I think that this is we're gonna see a lot more use cases of this, or a lot more attempts at this, and I'm excited for that as well. But I think right now this concludes the demo. Thank you for your attention. These slides or this application that I used to present it will be on my GitHub, so feel free to check it out, maybe play with it as well, and kind of see how it's implemented. And I'm excited, what you can do with computer use, and I'm excited for how this field is gonna progress. So thank you.